Hi, welcome, thank you for coming. My name is Sasha Goldshtein. I live in Israel and work at a company called scalable. We do training and consulting around Microsoft technologies mostly. And one of my jobs is an Azure Microsoft Regional Specialist, which basically means I try to help customers migrate to Windows Azure, understand if Azure is working well for them. And so it's pretty natural for me to give this talk on mobile backends, modern backends for mobile applications. And I will talk about Azure, and Azure is going to be one of the specific examples I'll show, but I'm not locking you into anything, and I'll try to keep an open mind, and you should keep an open mind as well, for other solutions that aren't Microsoft necessarily. It just happens to be the case that it's easier for me to demonstrate this stuff using Azure. I also really like Azure personally, but if you're interested in any other backend technology that I'll mention today, please feel free to discuss it. The reason I even submitted this talk to the conference is that I think lots of us are working on mobile applications or are thinking about mobile applications, maybe seeing mobile applications in our future. And there is this effort of building a backend that goes hand in hand with building the front end, with building the actual UI, the application, whatever runs on the device. And it seems that in many cases, especially when you're getting started with a mobile app, wasting all this time, spending all this time on building the backend could be really wasted time, because you might end up just discarding the whole thing. You might find it was just a prototype, never going to work, and so you're throwing away not just the front-end applications, but also the backend that you built. And it's now common for platforms, for cloud providers that provide cloud platforms, to also have this separate set of offerings called backend as a service, mobile backend as a service, which is essentially a kind of platform as a service, and we'll talk about some details later, specifically tailored for mobile applications, for modern mobile applications that have to store data in the cloud, send push notifications, authenticate users, a bunch of cross-cutting concerns like these, which any mobile application pretty much needs, and some websites need as well. And it's only natural for a cloud provider to provide this whole package for you to use, so that, at least theoretically, you don't have to write a single line of code to get this backend pre-configured for you. So I'd like us to do a little exercise in estimation. And this is an application, an Android app, that I've actually built a few years ago. It doesn't have the most modern look and feel, but it's not quite as simple as it looks. It's sort of it's an app for renting apartments. It's called Netlandroid. Netlan in Hebrew is an acronym which is short for real estate. So Netlandroid is an application for renting and selling apartments, which sort of made sense to me at the time. And it's got a few screens, as you can see here. It's got this main screen with search and favorites, and users can send messages to each other. And if you're looking at an interesting apartment listing, you can contact the owner, and the owner can contact you back, and you can schedule visits. And there's a bunch of additional functionality in there. And of course, there's a map, and you can add apartments, and you can add pictures, and you can add comments, and you've got checklists, and so there's a bunch of features there. So the exercise in estimation is, how long would it take to build a backend for this thing? I mean, building the Android app takes time, okay, but let's ignore that for now. How long would it take to build a backend that has the apartment listing, the messages, the communication, the push notifications, the whole authentication business? Just a ballpark number. Years, decades, thousands of man-years, a NASA large project. No, seriously. What would you say? 3 days. Isn't estimation great? What's that? A month? Several months, okay. A week? Did I hear a week? Yeah, okay. Did you say that? I don't see. Maybe it would take you a week, okay. Here's a fellow speaker. Okay, so ranging from 1 week to several months, I think I put myself somewhere down the middle. And what I'm trying to say is that it might actually take longer to build the backend than to build the actual mobile application. And in any case, if I were prototyping, I'd really like this backend to just be sort of available for me, at least when starting out. And that's what mobile backends are all about. That's what the modern mobile backends for mobile apps are all about. And then I actually should have connected my clicker so I wouldn't have to do this. But just press space. We'll need friction-free, hassle-free, free-to-get-started backends for our mobile applications, for our websites, for anything really that needs to store data in the cloud, access it in a simple way, authorize users, send push notifications. And these are actually some of the scenarios which I'd say backends like this could be useful in. So one thing I've already mentioned is just proof of concept or minimal viable product development. If you're just starting out, you're not sure this thing is even going to last, then focusing just on the client side, getting a few scenarios out in the hands of your users makes a lot of sense, and you don't want to focus on the backend. And so lots of startups that we're working with are actually exactly in this position. They are building mobile applications. I mean, do you know a startup that doesn't do mobile these days? I'm not sure I can even think of one. So everyone's trying to build mobile applications, and they don't want to focus on and invest in the backend if they don't absolutely have to. It's like they, for years, we're not building our own data centers when starting up a startup, right? It makes sense to host virtual machines somewhere else. And so the same thing is pretty much happening with the whole server infrastructure, the application, the platform that handles the backend for those mobile applications. Another thing, another scenario where this kind of backend could be really useful is elastic loads. And so building a distributed system with the sufficient scalability to handle millions of users and extremely elastic workloads is hard. And it's just sufficiently hard for lots of companies to fail at trying to do this. And so if someone at a cloud scale, like Facebook or like Microsoft, offers you a backend with scalability guarantees, it might be worth looking into that. And finally, the third point is that lots of companies today have already a very front-end oriented skill set. So you have lots of web developers, you might recruit mobile developers, and they're really good at making an iOS application, and they're really good maybe at databases stored on the iOS device. Not so good about huge scalable databases that have to run in a cloud environment. And so again, that's sort of a concern that you want to offload to someone else. And later in this talk, we'll actually talk a little about scenarios for offloading. So do you have to put your whole application in the cloud? Can you sort of do a hybrid thing where some resources are still in your environment managed by you and some resources are handled by the cloud provider? We'll get to that. Now, the key offerings, the features that these mobile backends actually provide, before we get to naming names and discussing specific offerings, specific providers, the key features are essentially data storage. So they're all focused at giving you some nice table-like abstraction for storing your entities, your objects. Occasionally, it looks like a SQL database. Occasionally, it is a SQL Server database, but it might be something a bit different. So you get an abstraction. You're not handling the specifics of the database server. You're not managing the database. You just pay for a certain amount of data, and you don't care how exactly it's handled by the backend. Another obvious feature is queries and caching. So the client applications issue queries to the backend. They have to run fast. They have to be cached on the client device. There has to be a whole framework for invalidating caches, for storing stuff on the device. So this whole business of caching and querying data has to be handled by the cloud provider. Push notifications are a pretty major concern. It's not that easy to send push notifications today. It is just HTTP. It's just a bunch of HTTP requests to various endpoints. But there is first the concern of actually managing registrations. You have to know which devices exactly are interested in which push notifications. And that's a lot of data occasionally and a high rate of queries and writes. And the other thing is that sending notifications, when you have so many push notification platforms, is actually a lot of code. So there's a separate piece of code you need for sending notifications to Apple devices. And for Android, you've got the stock Android, the Google services, and you have the Amazon services. And you have to use two separate kinds of APIs to send pushes to Kindles and pushes to standard Android devices. And if you have users in China, then you have to use a third set of APIs altogether. And so this whole abstraction around push notifications on top of push notifications, again, can be pretty useful. If you can just sort of forget about the complexity and just tell the backend, please deliver this notification to the 5 million users I have, and do it as fast as possible. And finally, user management is something mobile applications obviously have to take care of. So the mobile backend providers have to give you a way of creating your users, managing them, registering the users, storing passwords securely, which isn't that easy, and integrating with third-party authentication providers like Facebook and Twitter and Google. So instead of logging in with application-specific credentials, you just authorize through Facebook or through Twitter. And that's getting pretty common these days. So all these things and more are features of a lot of specific providers, and here's a list of a few. So Microsoft is a big player here. They weren't the first to the market, but they have today a very stable offering, which I'll show you during the demos. It's called Azure Mobile Services. It's a backend tailored specifically for mobile applications, and it supports pretty much all the mobile platforms you can think of, including Kindles and Blackberries and essentially anything that can talk HTTP can use these services. Facebook have acquired a startup called Parse, which I think were one of the first players in this market. So today it's a Facebook offering with the full cloud scale Facebook can provide. And we'll talk about Parse a bit later. This Android application, which I've shown you, actually uses Facebook Parse and doesn't have a single line of server-side code. So the whole backend is just stock Parse, whatever Parse provides out of the box. Box, Backend as a Service Box, is an open source project which isn't hosted by anyone. You download this thing and then you run it on your own servers. So it doesn't take away the complexity of managing the servers, it does take away the complexity of building the whole backend. And again, it handles data storage, it's got a bunch of extensions for various databases, it's handling authentication and pushes. Appcelerator is another provider. There's a bunch of additional options there. There used to be a great company called StackMob, which shut down actually a few months ago. So there's lots of players here. I think Microsoft and Facebook are the players that aren't going away anytime soon. So that's where I'd put my focus anyway. And when we talk about pricing a bit later, I'm going to compare Facebook and Azure side by side. And you'll see that in some situations it might make sense to choose one or the other. In any case, speaking about pricing, everyone has a free plan. So you can always get started and actually store a bunch of data in the cloud, have dozens of devices, dozens of users before you pay anything. So for development, for testing, most of these solutions would be free for you to use. And if you end up going to production, you might want to switch to your own solution or just keep using their backend and pay them a little every month. And again, we'll talk about pricing a bit later. So let's see a quick demo of getting started with Azure Mobile Services specifically. And if you'd like, I could also do this with Facebook Parse. In both cases, there is a very, very simple workflow for creating your first mobile application. So I'm going to go to the Microsoft Azure portal. And hopefully you can see this. Can you in the back see the fonts? Yes? No? OK, I'm going to zoom in a bit. That's as big as I can make it, still keeping it reasonable anyway. So this is the Microsoft Azure portal. If you haven't used Azure before, it's just this place where you manage all your stuff that you put in the cloud. And there is a separate tab here for mobile services. And I'm just going to create a new one. Yeah, OK. So I do have to zoom out a little because it just doesn't fit on the screen otherwise. I'm going to zoom in manually. So I just go to mobile service, create. We need a name. I'll go with software architect. Let's see if that's taken. No, that's available. And it can create a new database for me or use an existing one that I already have. I actually seem to have one in West US, so I'm just going to stick with that. And the backend doesn't really matter for us in this particular demo, so I'm just going to go and hit create. Oh, yeah, well, I need the password, which I don't remember. So I'm just going to create a new SQL database instance, which is going to be in North Europe, which is a little closer to where we are. And let's call it Software Architect DB, sounds good. And I'm going to create a new database server. And it's going to have a login name of Sasha. And the password, which hopefully fits. OK. And that's pretty much it in terms of just creating the initial backend. Now, what's happening now, and that's the part that takes the most, is that the database server is being provisioned for us. And that could take a few minutes, hopefully not. But the service itself, the backend, is actually just a bunch of simple web services running on a shared infrastructure that's already there. So the part of provisioning the mobile service itself is very, very quick. In any case, if it doesn't complete quickly, we can just take a look at the existing service for now. So if I click an existing service, the Azure portal says, OK, your mobile service was created. Now let's connect it to an application. And I need to choose a platform here. And just to make this session a little more interesting, I'm going to show you Windows later. But for now, I'm going to stick with iOS and Android. So if I pick iOS, it says, OK, would you like to connect an existing iOS app? Or would you like to create a new iOS app? In which case, you'll need to install Xcode, which is the development environment for iOS. You'll need to create a table. And that's on the back end, of course. It creates a to-do item table by default. And then finally, you'll need to download and run your personalized application. It just zips up a template, which you can download and run right away, already wired to your mobile service backend. Now, let's see if the actual service is already here. Yeah, there it is. So I'm just going to go through these steps. I'm going to create a table. And that creates an actual table in a SQL Server database. But again, it's all abstracted away for us, kind of. And then I'm going to download and run my app. And as you can see, Swift has only been generally available for a few weeks. But Microsoft already have a template using Swift and a template using Objective-C. So let's go with Swift. I actually haven't tried this template yet. So I'm going to click Download. And it's generating and downloading for me, again, a project that I can just open in my development environment, which will connect to this mobile service. It's taken a little longer than usual. OK, there it is. It's a zip archive. So open it with archive utility sounds good. And 14 seconds remaining. And I've already got Xcode open. So we'll just need to open that project in there. OK, there it is. And so I just go to Xcode. Let's try to make things fit here. And I'm going to open a project that sits in my download folder. A bunch of files here. So Software Architect, here it is. Opening. OK, and just to make sure that we really have an application here, yep, that looks like an iOS application. And I'm just going to be really brave and try to run this thing straight away. So it's going to run on an iPhone 6 simulator, which probably won't actually fit the screen. I'll have to, yeah, I have to rescale it. And this, by the way, is a good reminder of how phones have crazy resolutions. So let me just scale this thing down to 50%. And now it sort of fits. So this is my personalized starter project that mobile services generated for me. And it's actually connected to something. So let me just click this plus button over here. Opens up a new screen that says add item. And so we always need to buy flowers, right? I'm going to do save. And here it is. And also probably call spouse. Politically correct for the win. So we've got a couple of items that show up in the application anyway, but is this really in the backend as well, or is it just faking the whole thing? So if we go back to the Azure portal and go to the data tab, I hope everything's fine. And we click the to-do item table, then eventually we'll get the actual data that's in the table. And that was generated by the mobile app. And it's also got a completed flag, which is false. And so assuming that I actually bought the flowers or called my wife, if I refresh, then hopefully again we'll see a true in the completed column. Coming up. Well, you trust me, don't you? That it is actually complete. In the meantime, I'll just terminate the application and run it again just to make sure the changes really were persisted. Yeah, so it does look fine. Now, that's the iOS starter project. And of course, you're interested in the code probably. But before we take a brief look at the code, I just want to do the same thing with Android. I mean, they promised me a backend for all my mobile platforms. So if I just go back to the portal, go back to the quick start page, there's an Android section in here. And very similarly, it tells me to download the Android development environment, which happens to be free as well. It tells me to create a table, but we already have a table. And it tells me to download my personalized starter project. So I will download my personalized starter project. It's even smaller in the Android case. There it is. And then I can go back to my Eclipse. And I'm going to import existing projects into Workspace. And my project is somewhere over here. So, Software Architect 2. There's the project. And I'm going to click Finish. And sure enough, in Eclipse, we have our project. There it is, with a bunch of source files describing this to-do list application. And let me just run this thing for you on the emulator, which I happened to prepare. Emulator, where are you? Oh, there you are. Come here. OK. And the app should start. There it is. Well, they haven't got the title right, but other than that, it looks fine. It's refreshing right now, so it's grabbing the data from the server. And it's offering to add a new item, probably a connectivity problem here. Well, it should say buy flowers. There it is. See, the magic hand. So buy flowers is there, and on the Android UI, you check items to complete them. And we can add a new item, which is move on with the session. Oh, OK. And the keyboard stopped working. So I'm just going to do move on and click add. And if we go back to the iOS simulator and refresh over here, then here it is. So I know it all seems magical, and we haven't written a single line of code, and someone just generated these startup projects for us, and they're probably doing a lot of work in the background. But in fact, it is nice that you can get started so easily. And that's the whole idea of these startup projects. You create your mobile service, and then you can start experimenting right away.
And what Microsoft provides, and this is what makes the whole thing possible, is a bunch of SDKs for the various mobile platforms. So there is an SDK for Android, for iOS, for Windows Phone, for Windows 8, for Kindles. There's an SDK for everyone. And these sample projects show you how to use this SDK to connect to your mobile services. So just to show you a tiny example of what it would look like, for example, in the Swift case, there is here a to-do table view controller which connects to my mobile service using the software architect URL and an application key which was generated when the service was created. And then the code here connects to a table called to-do item. So it asks the server to connect to a table called to-do item. And then right down here, it says, there it is, table.read with predicate, and the predicate is complete equals no. So we're only grabbing incomplete items from the server. And read with predicate takes a callback, which is invoked when the results from the server are available. And these results are over here, a dictionary, and then there's some code over here that parses the results. But what I'm saying is that to connect to a table hosted in the cloud and grab the data in that table, you need somewhere between 3 and 6 lines of code. And you haven't spent any time building the web service, which returns the results to you, and you haven't spent any time configuring the database server, which returns the results to you. And it's also pretty similar if you look at the code for adding items, updating items, deleting items, so I'm not going to bore you with all these details. The conference is called Software Architect, so I'll try to move on to other concerns, other features, and towards the end we'll also talk about pricing, and of course we'll also see an example of the .NET SDK, which might be even more relevant for some of you. So what do we have at this point? We have a simple service running in the cloud, managing a database for us, which we can use to store and retrieve data. And data, again, is one of these things that's really nice to get from a cloud provider, but we also care about push notifications and user authentication, and we're going to address that as well. Before we do, I'd just like to talk about a few deployment scenarios. So one deployment scenario, which I call here complete reliance, is what the cloud providers would rather you do, and that means you just upload your whole logic to the cloud and forget about it. So there's nothing on premises, there's no code running in your data center. Everything is hosted by the mobile service provider. Could be Microsoft, could be Facebook, could be someone else, but anyway, your entire solution is running in the cloud. And that's, of course, what they're tailored for. This is the scenario they address most easily. And so particularly with mobile services, you can have a database for storing data. You can have a service inside Azure that handles push notification registrations and sends push notifications to interested clients. You can have file storage integrated into your solution, so you can store large files and not just stuff that would fit in a relational database. And whenever you do need some custom server-side logic, you don't build it on premises, you integrate it into Azure in one of two ways, specifically with Azure Mobile Services. If you like JavaScript, you can write so-called server scripts, which are essentially little scripts that take in requests and produce responses from your mobile applications. If you fancy .NET, then you use Web API to extend the service provided by Microsoft with your own Web API controllers, which can do pretty much anything with the resources you have in the cloud. So it is absolutely possible to use mobile services in this way. And again, that's what Microsoft would rather you do. This is what Facebook would rather you do if you're using Parse. They want you to put everything in one basket, to put everything in the cloud basket, and to extend where necessary, using only the minimal necessary changes. So in the case of mobile services, it would be little pieces of code that run on the server as part of this whole hosted environment. in some cases, though, there are some concerns which you simply cannot trust the cloud with, or you already have an existing solution that you have to integrate with a cloud offering. And so here I have a couple of examples. One is what I call offloading. So, for example, suppose that file storage is a concern you'd like the cloud to handle for you. You trust Microsoft with a huge amount of files, large files. Backing up those files, storing these files are things you don't want under your control. You don't want to store these files in your data center. You don't want to spend time making them available to geographically distributed clients. So you trust mobile services with file storage, and the rest is in your data center, on premises, some other hosting provider, whatever it is. Azure Mobile Services can actually make this kind of scenario work, even if the service itself needs access to your on-premise resources. And this is an area in which Microsoft has a better position than Facebook Parse. Parse is really tailored for the first scenario, where everything is running in the cloud, whereas Microsoft have a bunch of solutions that let you do bidirectional communication from your on-premise services to Azure and the other way around. Again, without getting into too much details here, your backend running on your servers can access mobile services using simple HTTP calls, just the way the client application can talk to the mobile service. Of course, your own backend code can also consume the mobile service in the same way. And the mobile service can talk to your on-premise resources using a new technology announced at TechEd called hybrid connections, which in a nutshell lets you expose a resource running in your data center to a mobile service running in the Azure data center. And the classic example is sharing a SQL database like this. So you have a large database that you are already using for other applications, and you want the Azure mobile service to talk to that SQL database from the Microsoft data center in a secure way that can be managed and audited and administered properly. So this is another scenario that you might find mobile services useful for. You have this large amount of files you want to put in the cloud, and the whole, all other aspects of the application remain in your data center. Another example of this is with occasional bursts. And this is a scenario I've actually seen a lot, at least in my work, related to push notifications. Sending a couple of push notifications to a couple of devices isn't a lot of work, doesn't require any super duper scalability, durability, or anything. It's pretty easy to send a couple of push notifications. But occasionally, our customers need to send hundreds of thousands, or millions, or maybe tens of millions of push notifications at once. Think of a sports application, a news website. The Olympic Games, the Winter Olympics and the Summer Olympics had mobile applications which would receive push notifications about interesting sports events. So there might be a case when you suddenly have to send 10 million push notifications as fast as possible, so clients don't lose any updates. This kind of scenario is also quite suitable for Azure, for either mobile services or another Azure offering called notification hubs. And this is, again, something that Facebook Parse provides, but I still think Microsoft has a better position around because they have this mass push service, which really can deliver millions of push notifications in a really short amount of time. And so your whole system can stay in your data center. You can keep developing it as you usually would, but for push, you offload the work to Microsoft. Whenever you need to send a large number of push notifications, you ask the cloud to send these notifications for you, and you only pay anything really if you use the service. So whenever you have this burst of 10 million push notifications, you have to pay for sending 10 million push notifications, but as long as you have months of inactivity, you're not paying anything to anyone. And so this is a solution that can also benefit from offloading parts of your mobile infrastructure to the cloud. So having discussed some of these scenarios, I'd like to show you another demo, which is this time a Windows 8 mobile application, which you could run on tablets, for example, that kind of simulates, again, the scenario of renting apartments, showing apartments for rent, showing apartments on a map using mobile services. So let me quickly switch over to the Java auto updater. I'm going to dismiss it for now. And let me just show you the Visual Studio project. So this time everything is managed, everything is C#. I have a Windows 8.1 application, and I have the mobile service backend. I have it open in a Visual Studio solution, but of course I've published it to the Azure cloud. And it's essentially a web API, an ASP.NET Web API project. Nothing particularly interesting about it. It's got a bunch of controllers. It's got connection strings. It's all pretty simple. Now, let me just run the application first, just to show you what it's like. Yeah, so it's a little ugly in this resolution. On the left, though, we should see a list of available apartments that are retrieved asynchronously. I've actually added an apartment with this address, pub at London, and it resolved to something. You can rent apartments, and you can delete apartments, and you can add apartments. I'm not a UI person, but I think it's pretty reasonable. Let me try, for example, to add another apartment. So what is this room called? Benjamin's Bar. Let's try. OK, so we get an exception. Obviously, to a user, you'd show something a little more polished. But the exception says, mobile services invalid operation exception. The request could not be completed unauthorized. And this shows you that we can definitely build the infrastructure for requiring users to authenticate before they can make destructive operations like adding apartments, updating apartments, and deleting apartments. OK, so let's see the authentication workflow. I can log in using this button over here. And this opens what looks like a website. And this is Twitter asking me to authorize rentahome.net to use your account. I will be able to read tweets from your timeline and see who you follow. Now, I have a user exactly for that called John McUser with a password. Funny story about John McUser is that every time I use this user in a demo, Twitter sends me an email. Hi, John McUser. Welcome back to Twitter. Here's what you've missed. So I'm going to get one of those. Anyway, I just sign in, authorize. And so there is actually a label right here, right? Imagine there's a label here that says you are now logged in, which you're not seeing. But I am now logged in. And so if I try to add this apartment again, you see it was added. And we got a nice push notification. Now, you'd argue that if I added this apartment listing, I shouldn't get a push notification about it. And yeah, it does make sense, but I don't have two machines here. So I'm sending this push notification to everyone as soon as there is a new apartment listing in the system. OK, so the apartment's over here, and we've got some basic authentication going on, and we've got a push notification, and I'll show you the code momentarily. Before that, let me try to monetize this solution. So suppose we have this amazing application installed on millions of devices, and now I'm selling ads to my customers, my shady, dark, third-party vendors. And they can send push notifications directly into each and every user's app. So they're coming for me. So that's a service I'd like to offer. So I want to give third-party vendors a tool that would send ads as a push notification, maybe tailored to specific users, to specific regions, to specific languages, to specific time zones. So I have this little command line tool over here. Let me just make the prompt disappear. I have this little tool over here called Rent-A-Home Ad Console. And it's a console application, sure enough. And it can list me all the registrations that are currently in the mobile services database. These are all the registered client devices, which I only have one of, which will receive my push notification. And these registrations have an arbitrary set of tags. And what I'm using for tags here is just the user. So I have a distinct tag for every user, but you can envision tags for cities, countries, languages, time zones, interests, and so on. Maybe even platforms. So you want to send different pushes to iOS users than to Windows Phone users. In any case, when targeting my push notifications, I can use these tags now. But again, I only have one, so one registration. So I'm just going to send a simple ad right here. Come to my other talks tomorrow. And I hit enter. And here's the ad showing up pretty instantaneously. This was delivered to us by the Azure cloud. And all other millions of registered devices would have received this ad at once. So I realize this is not the way you should use push notifications normally. And in fact, some platforms prohibit you from using push notifications to deliver advertisements. And it does make sense in a way. But I think it's a nice example of a scenario where you really want to just sort of deliver the notification at once to as many users as possible. So it could be ads, could be breaking news, could be coupons in your area, anything else that might be interesting and urgent for the user to look at right away. And again, in terms of code, there really isn't much code here, which is the fun part. The mobile services backend layer really takes care of most of the concerns. So for example, to send a push notification, I need roughly 3 lines of code from my backend, which are constructing a payload, which depends on the platform. And there is actually a way of building a single payload that will work on all platforms, but I'm not going to cover that today. And then just calling an API specific to the platform. So to send a Windows push, you called one method. To send an iOS push, you call a different method. And so if you have your users already broken down to separate tags by platform, you can send push notifications like that. And again, there is also a way of sending cross-platform pushes, which I'm not going to talk about here. I just want to illustrate the fact that you roughly need 3 lines of code to send the push notification when you're using a nice library that abstracts away the backend, which abstracts away the push notification services. And similarly, for authentication, this whole flow of authenticating the user with the Twitter application and getting their credentials and token and all that, the code for that is in the client app, of course. So somewhere under the whole screen of using directives should be a method called login click, naturally. And so to log in the user, we call this one single method provided by the mobile services SDK called login async. And that's really all there is to it. The client-side framework is responsible for showing this authentication UI, for talking to Twitter, for getting back from Twitter a token that you can then use to authenticate client calls to the mobile service, and even for storing that token on the device so the user doesn't have to log in again every time you open up, every time they open up the mobile application. So again, this whole authentication business is nicely abstracted away by someone else. And just so that you don't feel I've left out other cloud providers, I would like to just show you a quick walkthrough of what this would look like with Facebook Parse. And then we'll move on to pricing and other architectural concerns. So if I just go to parse.com, this is the Facebook offering, which is, again, a backend for mobile applications. I can log in or sign up. And, well, let me actually just do it real quick. So this is my email. And I hardly remember my password, so good thing is I have a RoboForm. And I'm encouraged to opt into new pricing. which is exciting. In any case, I will now create a new application, and we'll call it Software Architect. And it has been created, and so now I can go to the quick start guide. Can I make this thing go away? Probably not. I mean the banner. In any case, under the app itself, I have documentation for a bunch of different products. So I can use the data services to store stuff and retrieve stuff. I can use the push services. I can use the authentication services, the social services. If I click data, for example, I'm asked to pick a platform. So I'm going to go with mobile and say Android. And then suppose I'm using Java. And then suppose I'm using a new project. So again, you can see where Microsoft is getting the inspiration for this. Please go ahead and download a blank Android project that connects to your backend, which we have already provisioned for you, and starts issuing requests. And there is, of course, a data browser, just like the one I've shown you in the Azure portal. There is actually a nice feature here that Microsoft doesn't have, which is sending test push notifications. So again, the offerings are pretty similar, but the user experience might be a little different depending on the backend provider you choose. But they are all very interested in getting you started as quickly as possible. So create your application, download a starter project, start using the service, and then you see it really does work on all the platforms, and then you start working on your own project. Drop the mic, quite literally. OK. Right. So going back to the presentation, because I do want to leave a little time for questions as well towards the end. And the one thing I want to talk to you about is pricing. The pricing model for Azure, for Facebook Parse, and maybe for the other services as well. So now, obviously, you could build this whole thing yourself. The question is how much it's going to cost you. And to understand if it's reasonable or not, you need to look at the pricing for these backend services. So let's start with the Azure side. The Azure pricing is in so-called units, and you have to pay for a whole unit. You can't pay for less than a unit. And the single unit of the simplest kind costs $15 a month. And for $15 a month, you get 1.5 million API calls, which can be data queries, requests to send push notifications, essentially any interaction with the mobile service itself. So 1.5 million API calls, 10 million push notifications delivered to client devices, unlimited CPU capacity and data transfer, which means unlike other cloud services, you are not charged for whatever the mobile service is doing in the background. You pay the $15, you get this many API calls, this many pushes, regardless of how much actual traffic or how much CPU it required. And finally, storage and the database are priced separately. So if you have a lot of data, you might find it necessary to create SQL databases in Azure, which have a separate set of pricing. And I have a scenario, a specific pricing scenario that we'll get to in a couple of minutes. So the Azure pricing model is that you pay for units, and $15 is enough for, well, it depends on the application, of course, but it could be enough for dozens of thousands of users in some cases. So that's the Azure pricing. The Parse pricing is slightly different. You pay for resources, for individual resources separately. There is a free tier, which you get per month without paying anything, and then you have to add extra. So one thing you get for free is 30 requests per second. You get a sustained rate of 30 requests per second that your service can handle. If you need more, you pay $100 extra per 10 requests per second. So this can add up. But it's an interesting model in which you get a lot for free. You get 20 gigabytes of file storage free and 3 cents per gigabyte extra. You get 20 gigabytes database for free, and you add $200 for 20 gigabytes extra. And you get 2 terabytes of data transfer free, data coming in and out of your service every month, and you add 10 cents per gigabyte extra. So you see it's more granular. If you're sending lots of push notifications which have really tiny payloads, then your data transfer is going to be real small. If you have only a small amount of data you're storing in your service, then 20 gigabytes database could be enough for millions of users, theoretically. So you could get by with the free tier, all in all, and you can pay for whatever specific resource you need extra. The one pain point is this requests per second business, because 30 requests per second, if you add this up over a month, you get to a point where you have to, for really popular applications, to add lots and lots of money to augment this, this quota. But the other pricing points are pretty reasonable, I think. Now, if we look at a particular specific scenario, suppose you're building an application for a credit card company that they provide to their users, and it's got some push notifications. The user gets offers, coupons, billing information, and the user can also proactively open the app and see their bill, see, again, any coupons, offers, whatever it is, and maybe even pay the credit card bill at the end of the month. So suppose we have 1 million active devices a month, which is pretty optimistic. We have 8 million people in Israel, so an application with 1 million active users is, I'd say, fairly popular. But I think even for the UK, 1 million active users a month is a good thing, is a good situation to be in, right? So you have 1 million active devices a month. You're making an average of 2 API calls per day per device. That sums up to 60 million API calls a month. You send an average of 1 push notification per day per device. If you send more, users are going to be pretty annoyed with you. And you store an average of 100 kilobytes of data per user or per device, whatever works for you. And that's 100 gigabytes of data. So you can get all that, with Azure anyway, for just a little over $1,000 a month. You need 3 standard mobile service units, which cost $560. And you need 1 instance of SQL Server running in the cloud. And it's a pretty expensive SQL Server configuration, which offers you 500 gigabytes of storage and a rate of 100 transactions per second, which is guaranteed by the SQL Server database. And that costs $465 and also includes some active support and a bunch of additional features which you don't really need, but they are part of this SQL Server offering. So for just a little over $1,000 a month, you can support 1 million active devices, which I think is, well, pretty good. And I'm really not sure if you can build something like that for less. So that's one pricing point. The other pricing point, of course, is free. And as you see with Parse, for example, you get a lot for free. So just think about it, 30 requests per second, 20 gigabytes file storage, 20 gigabytes DB, and 2 terabytes of data transfer you get as part of the free tier, no strings attached, which is pretty crazy, actually. So it's definitely easy to get started, and there's a lot you can do with the free tier. As soon as you need more, the pricing is very flexible. The Parse pricing, by the way, is prorated monthly. So at the beginning of the month, you pay for so many extra requests or extra gigabytes or whatever. The Azure prices are prorated by the hour or maybe by the day. So if you have this really active weekend with lots of push notifications, you pay for that weekend. You're not paying for the whole month if you're not planning on using these resources throughout the whole month. So that's really a plus. So that's pretty much it for pricing. The other providers, again, they have their own plans, but pretty much everyone has a free tier and makes it really easy for you to get started. So the last thing I'm going to talk about, which sort of wraps up the theoretical part of the talks and leaves a little time for you, for questions, for a discussion, is the pros and cons of going with this kind of mobile backend provided by some arbitrary cloud provider, Microsoft, Facebook, whatever. On the pros side, we have the elastic scale. You can really scale this thing up and down. You can come over in the morning, and create 5 additional databases and then just take them down at the end of the day. You can create 10 additional units that can send 50 million push notifications and take them down at the end of the day. And you only pay for what you use. And that's the case with Facebook, with Microsoft, with all the backend providers that have their own cloud, where you don't have to actually host this backend on your own systems. We've got productivity, of course. You're not building the backend. That's a big advantage. And in many cases, these backends are really pretty powerful. So they have lots of features. It would take you many years to develop. It's cheap for common scenarios anyway. As you can see, you can support reasonably 1 million active users for $1,000 a month, which is pretty cheap. And in most cases, there's really lots of flexibility for customization. So for example, Microsoft have this concept of server scripts or web API controllers. Parse have a concept called cloud code, which is, again, you uploading pieces of code that customize the hosting environment. So there is opportunity for customization. It's not like you're buying this black box of a backend, which you have absolutely no insight into. On the con side, integration with on-premise resources can occasionally be pretty challenging. Microsoft have this hybrid connections offering and service bus relay and a bunch of additional tools that can make it possible to connect to whatever you have on premises, but still it's not as smooth as if you just put the whole thing in one basket, in the cloud basket. And finally, uncommon scenarios can be pretty expensive. So just to give you one example of that. Suppose you have a really crazy, absolutely insane number of users, like hundreds of millions of users, right? But you only store a little data for each user. So if you multiply the number of users by the amount of data, it doesn't add up in exactly the same way in terms of pricing as it would if you had 10 times fewer users and 10 times more data for each user. So occasionally, if you're using the platform with a huge number of users but very little data, very little customization, you're basically using the platform as an authentication and push platform and not a data platform, you might end up paying a lot more than for a comparable solution of your own. So there are some scenarios where you really have to consider if a cloud backend would be good for you. But for the 99 percentile, it definitely makes sense to just start out with a cloud backend anyway. For new development, for proof of concept development, for the minimal product as you're getting started, for prototyping, it's usually a much easier and cheaper solution. So at this point, I'd really like to open it up for questions. If you'd like to take an additional look at any particular area of the demos that I've shown you, I can definitely do that. And so do you guys have any questions, please? I really do need some water. Yes, sir. Yeah.
So the 30 requests per second, does it further request it arrive in faster pace, or the users get service unavailable or something like that?
It does throttle you, and you will get timeouts eventually. Yeah. It's also the same with Azure. In a way, they're not explicitly saying what exactly happens when you go over the quota. They just have this provision in the documentation that says, if you go over the quota, we reserve the right to refuse requests. It also says here unlimited CPU capacity. And so you obviously can make just 10 requests which burn up a whole CPU for a month. So they also have some throttles on that, but it's unlimited as far as you should typically go. You don't care, so they don't tell you what you get. Neither Parse nor Microsoft work in explicit scale units here. So unlike other Azure services, you don't pick a VM of that size or the other size with that much RAM or that much RAM. You have to trust them. It's also the same with parse. They never, ever said anything about the virtual machines actually running their service. I believe they started out with Amazon, actually, AWS. Today, they probably migrated to Facebook's own data centers, but I'm not sure. Yeah?
At the moment, we use merge replication with Windows 6.5 mobile. And a lot of the demos I see for Azure Online are just one form, one table, rather than big relational databases with lots of different forms all the way through. How does Azure cope with that? Is it seeing that scenario yourself? Because a lot of the demos I see is just probably just one form, let's insert it, whether if you've got an asset management system that has to go all the way down.
Yeah. So in Azure, anyway, you get full control if you want over the SQL database. So it's a SQL Azure database which has roughly the same functionality as a full standalone SQL server. I say roughly because some features aren't available, but for most purposes, it's a SQL server that you can manage. And so you can have views and custom logic in the database and scaling and replication and so on. The mobile services layer, the abstraction they give you, is tailored for tables. So they do want you to talk to one table. But, I mean, you can totally override that. And in fact, there are NuGet packages that show you how to use mobile services with a different storage backend than SQL Server. So you can use Mongo, or you can use table storage, which is much cheaper in some cases than SQL Server. For parse, you do not get control over the database. So they don't give you a connection string. In fact, they're probably not using SQL Server. They're more of a Linux farm. So in this case, you do get this table abstraction. And you can make joins and basic stuff like that work. But if you need really sophisticated database stuff, then Azure would work better. Yeah.
How difficult is it to add this sort of functionality into existing applications?
What's that?
Sorry, how difficult is it to add this sort of functionality into existing applications?
Okay, so
both of them have downloads for new applications and proof of concept. What if you want to add some features to an existing app, make it put backend in about?
right, so it depends on what you're trying to add. So if you're so ambitious to replace your whole data management layer, just rip off your data management from the existing application, move it to Azure or to Facebook, then it depends on your layering that you already have. So if you already have some pretty factored out code in your client app that talks to a web service which handles all the storage, replacing that would probably be easy. If you're tightly coupled to a specific database, it would be harder. But adding some additional concerns, like adding push notifications or adding authentication into an existing application is easier. So if you're not just ripping out a huge chunk of functionality, it's easier. But it's definitely possible, like I've said, to use only the parts you need. So again, one scenario I commonly see is using a cloud for sending bursts of push notifications, or for authenticating users and just offloading the rest to your existing infrastructure. Yeah.
Is there support for offline apps where you're local?
Okay, so that's a great question about offline support. Initially, both Facebook and Microsoft did not have any offline support. So the application would have to at least occasionally connect to the internet to get sort of a workflow going. Parse were first to introduce offline. So basically, whenever you make a query, the results are cached. And when you reissue the query, you can ask for the client-side layer to just return the stale results if you're offline. And so you get at least a basic experience. At some point, they also added synchronization. So if you make destructive operations or add additional data, it would be delivered as soon as you connect, as soon as you're connected again. They also have a custom solution for push. So for example, on Android, if the application is disconnected, as soon as the connection comes back online, they have a service that actively seeks any push notifications that might have been missed. So they have a pretty good offline story. Microsoft don't have right now a very good offline story. They introduced just a few months ago support for offline synchronization, which started out in Windows 8 and moved to iOS as well, but they don't support all the platforms yet. The basic idea is that, again, you wrap the client-side layer with an additional layer that does caching and stores stuff in a local database, and it will pull from there if there is no connection. And it can also resolve conflicts. And actually, I have in this little demo I've shown you here, it has some offline support. So as you review the code, if you'd like after the session, I'll post the whole thing online, of course. You can take a look. And basically, if I turn on offline sync, I can make destructive changes. Sorry, I should have done pull first. No, it's not offline right now. It's in a mode that supports offline. Yeah, so the pull should have pulled. Oh, there it is. Right, so these are all the apartments we have. And so now I can, well, disconnect the network cable, I suppose, and delete this pub over here. And if I push now, it's going to push the changes back to the server. But I can work at least, I can do basic operations in an offline disconnected environment. If I do reconnect and wait a few seconds and then push, it just doesn't provide any visual indication. So it's a little hard to tell if it's working or not. But if I close down the app and just run it again, yeah, the change was pushed. I mean, the pub went away. It isn't particularly hard to integrate this, but you do have to think of conflict management as soon as you have this offline support, because data might be changed by another user in the meantime. So Parse has a better story right now around that. In a SQLite database. There's currently SQLite support for Windows 8, for Windows Phone, for iOS, and for Android, so it's a pretty natural solution. It's just a single file database. What's that? Well, the file itself could be stored on an encrypted file system. So on iOS, for example, actually in iOS 8, by default, the whole file system is encrypted, but you can definitely use encrypted storage. In Android, you can also use encrypted storage in newer versions, which means if the device is locked, you can't read those files in any way. But I mean, you could also add your own layer of encryption. By the way, one thing that needs encryption in any case is the user token. If you want an experience where the user doesn't have to log in every time you open the app, you absolutely have to store the token on disk, and then this is a piece of data that really has to be encrypted. Yeah?
When you sell the database, what's actually happening behind the scenes there? Is it in terms of the code that's generated? Is it ultimately creating a web API call or web API layer, which is effectively taking those database fields and exposing them to the clients via get, post?
Yeah, so
what's happening on the cover?
Well, there is a SQL Server database sitting in the Azure cloud somewhere, and it is not exposed to the outside world. It doesn't listen on any external ports. Microsoft provides you a web service that talks to the database, yes. And they also provide you a client-side library that talks to the web service that talks to the database. And so by default, you don't need authentication at all to issue requests to that web service, to that intermediate web service. And that obviously doesn't make sense in a real app. But they want to make the whole getting started process easy. But once you're past that point, you can secure the application so you can't make any operations against the database, against that intermediate web service without logging in first. And so that's what's happening here. If you recall, when I tried to add an apartment without logging in first, I get a 403, unauthorized. And you can make the same. You can have the same experience for reads. So the app wouldn't return any data unless you were logged on. Mm-hmm.
You mentioned user authentication with, for example, Facebook, Twitter, cross integration. What about how easy is it to do with, for example, corporate LDAP or what have you? Is that feasible?
Well, first of all, there is support in Parse for custom usernames and passwords. So Parse provides you the APIs for creating users, registering users, even validating emails, stuff like that. Microsoft, at first, only supported third-party OAuth providers. So you could use Google, Facebook, Twitter, Microsoft ID, that's it. Today, there is support for Active Directory, and Ido is smiling because he really likes Active Directory. And so you can use Azure Active Directory with mobile services. And Azure Active Directory is basically Active Directory in the cloud, which can manage users for you and can also synchronize with your on-premise Active Directory. So at the end of this process, you can use your corporate domain credentials to log into the mobile application. If you had a?
Hybrid connection to a corporate database server, would you just pay for the API calls and not for the data storage?
Well, yeah, in terms of your client, nothing changes. You still talk to that intermediate web service, to the mobile service that's sitting in Azure, and it can talk to a database hosted on premises instead of a database hosted in Azure. And from the mobile services perspective, it's just a matter of changing the connection string. So it's really nice. I mean, you don't even need any custom code for that. If all you want is to simply store the data in an on-premise DB instead of Azure, it's just the connection string, and the technology behind it is hybrid connections. Yes.
And the hybrid connection, would that go over port 80, or would it need other ports?
It uses, by default, port 80 and 443, so HTTPS. It also has another couple of ports that it uses if they are available, but I mean, the very bare minimum is HTTP and HTTPS.
So there's actually something installed on premise as well?
Yes, yes. It's a service you put on premises on at least one of your machines, and it tunnels the traffic to other boxes, other resources you have on your network. It's nice because it's really easy to set up. But if you need more, if you need an actual VPN solution where multiple machines on the Azure side can talk to multiple machines on your network, and so Microsoft do have an offering called Virtual Networks, which handles this. There's hardware VPN support and there's software VPN support, so it is all possible. I think Virtual Networks are only yeah, I think they are supported with mobile services, but it's if they are, it's a very recent development. It used to be a virtual machines feature. I think it's supported with mobile services, but hybrid connections definitely is. Yes?
With these highly abstracted SQL Server databases, what happens when things go wrong? What sort of services are available from these vendors?
Yeah, so I'm not sure what exactly you're asking, but if you're asking about the diagnostics story in general, well, so first of all, you have logs, lots of logs on the service side, which are generated by the infrastructure, and you can add your own logs, of course. You have remote debugging support. So you can, from your Visual Studio, attach to the mobile service process and set breakpoints and diagnose issues. You get the connection string to the database if you'd like. So you can connect to the database from your development machine and look at the database itself and what's going on. So there is a pretty good story around that. There isn't anything specifically tailored for mobile services. So there isn't a specific new diagnostic solution only for that. But you can use your existing tools. Mm-hmm. What's that?
Sorry, presumably Visual Studio connecting to the remote process, that's specifically for Azure.
Yeah.
What is this Facebook cars?
Parse does not have support for connecting to the service remotely. So you have logs and you have logs. Yeah. I'm just going to put up my contact slide at the end of the presentation, which also has the link to the presentation itself, in case you'd like to remind yourself of what we've been talking about. The code demos I've shown you will be on my blog, if you'd like to follow me, and I'll also post them on Twitter. I hope today, maybe tomorrow. Just another thing, I have 2 talks tomorrow as well, one on Xamarin, C# everywhere, using C# on mobile platforms, and the other is Swift, Apple's new programming language. So just plugging in my other 2 talks. And if you have any additional questions, please feel free to stay and ask. I hope you enjoy the rest of the conference, and really thank you very much for coming. Thank you.
Database server, you're not managing the database, you just pay for a certain amount of data and you don't care how exactly it's handled by the backend. Another obvious feature is queries and caching. So the client applications issue queries to the backend. They have to run fast, they have to be cached on the client device. There has to be a whole framework for invalidating caches, for storing stuff on the device. So this whole business of caching and querying data has to be handled by the cloud provider. Push notifications are a pretty major concern. It's not that easy to send push notifications today. It is just HTTP. It's just a bunch of HTTP requests to various endpoints. But there is first the concern of actually managing registrations. You have to know which devices exactly are interested in which push notifications. And that's a lot of data occasionally and a high rate of queries and writes. And the other thing is that sending notifications, when you have so many push notification platforms, is actually a lot of code. So there's a separate piece of code you need for sending notifications to Apple devices. And for Android, you've got the stock Android, the Google services, and you have the Amazon services. And you have to use 2 separate kinds of APIs to send pushes to Kindles and pushes to standard Android devices. And if you have users in China, then you have to use a 3rd set of APIs altogether. And so this whole abstraction around push notifications on top of push notifications, again, can be pretty useful. If you can just sort of forget about the complexity and just tell the backend, please deliver this notification to the 5 million users I have, and do it as fast as possible. And finally, user management is something mobile applications obviously have to take care of. So the mobile backend providers have to give you a way of creating your users, managing them, registering the users, storing passwords securely, which isn't that easy, and integrating with third-party authentication providers like Facebook and Twitter and Google. So instead of logging in with application-specific credentials, you just authorize through Facebook or through Twitter, and that's getting pretty common these days. So all of these things and more are features of a lot of specific providers. And here's a list of a few. So Microsoft is a big player here. They weren't the first to the market, but they have today a very stable offering, which I'll show you during the demos. It's called Azure Mobile Services. It's a backend tailored specifically for mobile applications, and it supports pretty much all the mobile platforms you can think of, including Kindles and Blackberries and essentially anything that can talk HTTP can use these services. Hi, welcome, thank you for coming. My name is Sasha Goldshtein. I live in Israel and work at scalable. We do training and consulting around Microsoft technologies mostly. And one of my jobs is an Azure Microsoft Regional Specialist, which basically means I try to help customers migrate to Windows Azure, understand if Azure is working well for them. And so it's pretty natural for me to give this talk on mobile backends, modern backends for mobile applications. And I will talk about Azure, and Azure is going to be one of the specific examples I'll show, but I'm not locking you into anything, and I'll try to keep an open mind, and you should keep an open mind as well, for other solutions that aren't Microsoft necessarily. It just happens to be the case that it's easier for me to demonstrate this stuff using Azure. I also really like Azure personally, but if you're interested in any other backend technology that I'll mention today, please feel free to discuss it. The reason I even submitted this talk to the conference is that I think lots of us are working on mobile applications or are thinking about mobile applications, maybe seeing mobile applications in our future. And there is this effort of building a backend that goes hand in hand with building the front end, with building the actual UI, the application, whatever runs on the device. And it seems that in many cases, especially when you're getting started with a mobile app, wasting all this time, spending all this time on building the backend could be really wasted time, because you might end up just discarding the whole thing. You might find it was just a prototype, never gonna work, and so you're throwing away not just the front-end applications, but also the backends that you built. And it's now common for platforms, for cloud providers that provide cloud platforms, to also have this separate set of offerings called backend as a service, mobile backend as a service, which is essentially a kind of platform as a service, and we'll talk about some details later, specifically tailored for mobile applications, for modern mobile applications that have to store data in the cloud, send push notifications, authenticate users, a bunch of cross-cutting concerns like these, which any mobile application pretty much needs, and some websites need as well. And it's only natural for a cloud provider to provide this whole package for you to use, so that, at least theoretically, you don't have to write a single line of code to get this backend pre-configured for you. So I'd like us to do a little exercise in estimation. And this is an application, an Android app, that I've actually built a few years ago. It doesn't have the most modern look and feel, but it's not quite as simple as it looks. It's sort of it's an app for renting apartments. It's called Nedlandroid. Nedlan in Hebrew is an acronym which is short for real estate. So Nedlandroid is an application for renting and selling apartments, which sort of made sense to me at the time. And it's got a few screens, as you can see here. It's got this main screen with search and favorites, and users can send messages to each other. And if you're looking at an interesting apartment listing, you can contact the owner, and the owner can contact you back, and you can schedule visits. And there's a bunch of additional functionality in there. And of course, there's a map, and you can add apartments, and you can add pictures, and you can add comments, and you've got checklists, and there's a bunch of features there. So the exercise in estimation is, how long would it take to build a backend for this thing? I mean, building the Android app takes time, okay, but let's ignore that for now. How long would it take to build a backend that has the apartment listing, the messages, the communication, the push notifications, the whole authentication business? Just a ballpark number. Years, decades, thousands of man-years. A NASA large project. No, seriously. What would you say? 3 days. Isn't the estimation great? Was that? A month? Several months? Okay. A week? Did I hear a week? Yeah? Okay. Did you say that? I see. Maybe it would take you a week. Okay. Here's a fellow speaker. Okay, so ranging from 1 week to several months, I think I put myself somewhere down the middle. And what I'm trying to say is that it might actually take longer to build the backend than to build the actual mobile application. And in any case, if I were prototyping, I'd really like this backend to just be sort of available for me, at least when starting out. And that's what mobile backends are all about. That's what the modern mobile backends for mobile apps are all about. And then I actually should have connected my clicker so I wouldn't have to do this. But space, we'll need friction-free, hassle-free, free to get started backends for our mobile applications, for our websites, for anything really that needs to store data in the cloud, access it in a simple way, authorize users, send push notifications, and these are actually some of the scenarios which I'd say backends like this could be useful in. So one thing I've already mentioned, services. Facebook have acquired a startup called Parse, which I think we're one of the first players in this market. So today it's a Facebook offering with the full cloud scale Facebook can provide. And we'll talk about Parse a bit later. This Android application, which I've shown you, actually uses Facebook Parse and doesn't have a single line of server-side code. So the whole backend is just stock Parse, whatever Parse provides out of the box. Box, backend as a service box, is an open source project which isn't hosted by anyone. You download this thing and then you run it on your own servers. So it doesn't take away the complexity of managing the servers, it does take away the complexity of building the whole backend. And again, it handles data storage, it's got a bunch of extensions for various databases, it's handling authentication and pushes. Appcelerator is another provider. There's a bunch of additional options there. There used to be a great company called StackMob, which shut down actually a few months ago. So there's lots of players here. I think Microsoft and Facebook are the players that aren't going away anytime soon. So that's where I'd put my focus anyway. And when we talk about pricing a bit later, I'm going to compare Facebook and Azure side by side. And you'll see that in some situations it might make sense to choose one or the other. In any case, speaking about pricing, everyone has a free plan. So you can always get started and actually store a bunch of data in the cloud, have dozens of devices, dozens of users before you pay anything. So for development, for testing, most of these solutions would be free for you to use. And if you end up going to production, you might want to switch to your own solution or just keep using their backend and pay them a little every month. And again, we'll talk about pricing a bit later. So let's see a quick demo of getting started with Azure Mobile Services specifically. And if you'd like, I could also do this with Facebook Parse. In both cases, there is a very, very simple workflow for creating your first mobile application. So I'm going to go to the Microsoft Azure portal. And hopefully you can see this. Can you in the back see the fonts? Yes? No? OK, I'm going to zoom in a bit. That's as big as I can make it, still keeping it reasonable anyway. So this is the Microsoft Azure portal. If you haven't used Azure before, it's just this place where you manage all your stuff that you put in the cloud. And there is a separate tab here for mobile services. And I'm just going to create a new one. Yeah, OK. So I do have to zoom out. It's just proof of concept or minimal viable product development. If you're just starting out, you're not sure this thing is even going to last, then focusing just on the client side, getting a few scenarios out in the hands of your users makes a lot of sense, and you don't want to focus on the backend. And so lots of startups that we're working with are actually exactly in this position. They are building mobile applications. I mean, do you know a startup that doesn't do mobile these days? I'm not sure I can even think of one. So everyone's trying to build mobile applications, and they don't want to focus on and invest in the backend if they don't absolutely have to. It's like they, for years, we're not building our own data centers when starting up a startup, right? It makes sense to host virtual machines somewhere else. And so the same thing is pretty much happening with the whole server infrastructure, the application platform that handles the backend for those mobile applications. Another thing, another scenario where this kind of backend could be really useful is elastic loads. And so building a distributed system with the sufficient scalability to handle millions of users and extremely elastic workloads is hard. And it's just sufficiently hard for lots of companies to fail at trying to do this. And so if someone at a cloud scale like Facebook or like Microsoft offers you a backend with scalability guarantees, it might be worth looking into that. And finally, the third point is that lots of companies today have already a very front-end oriented skill set. So You have lots of web developers, you might recruit mobile developers, and they're really good at making an iOS application, and they're really good maybe at databases stored on the iOS device. Not so good about huge scalable databases that have to run in a cloud environment. And so again, that's sort of a concern that you want to offload to someone else. And later in this talk, we'll actually talk a little about scenarios for offloading. So do you have to put your whole application in the cloud? Can you sort of do a hybrid thing where some resources are still in your environment, managed by you, and some resources are handled by the cloud provider? We'll get to that. Now, the key offerings, the features that these mobile backends actually provide, before we get to naming names and discussing specific offerings, specific providers, the key features are essentially data storage. So they're all focused at giving you some nice table-like abstraction for storing your entities, your objects. Occasionally, it looks like a SQL database. Occasionally, it is a SQL Server database, but it might be something a bit different, so you get an abstraction. You're not handling the specifics of